So these are the guided notes for section 8.4, compound interest for the financial chapter for Math 102. And here your compound interest formula is going to be A, or the future value, is equal to the principal times 1 plus the rate divided by the number of times compounded raised to the nt power. And our first example that we're going to look at is you deposit $9,500 into a savings account at a rate of 6%. The interest is compounded quarterly, and you leave the money in the account for 5 years. So we want to know how much money will be in the account after 5 years, and then how much interest is earned. So first, to figure out what will be in the account after 5 years, we will plug our information into our formula. So we'll say that A is equal to, and our principal was what we deposit, so $9,500 times 1 plus, and then it's the rate, which is 6%, so 0.06 divided by the number of times compounded. When it is compounded quarterly, that is 4 times a year. And then it's raised to the number of times compounded, so 4 times the number of years, which is 5. So again, order of operations, we'll do those parentheses first. When I calculate the parentheses, again, you never want to round your answers at all until you get to the very end. So I'm going to take order of operations inside the parentheses, do 6/100 divided by 4, and add 1. And that is going to give me, keep my 9,500 on the outside, times 1.015, and it's raised to the 20th power. And I just got 20 by multiplying the 4 times the 5. So now exponents first. So I'm going to take my 1.015 and raise that to the 20th power. On your graphing calculator, to do the 20th power, if you have a TI-84 or a Texas Instrument, right below the clear button and above the divide button is that it's a caret, and you punch that and then punch in your 20. And again, don't round until the very end. So when I raised my 1.015 to the 20th power, I still have my 9,500. This time it's going to be times 1.3468855,007. And again, I'm not going to get rid of anything off that calculator. And then I'll do my times 9,500 for my last one. And we're finding the future value, so we'll round normally, or as we normally would. So we have $12,795, and it's 0.12256. But when I round it, we're talking about money, so I'll have $12,795.12. And that's how much I'll make, or will be in the account after 5 years. So now to figure out how much interest is earned, this is what is in the account after the 5 years. So we're going to subtract the money that we put in. So we'll subtract our 9,500. And we end up with $3,295.12, and that is our interest. Just to find the interest, you want to subtract the principal amount, or what you put into the account. All right, so here we're going to compare we're going to use the same problem, we have an investment of $5,000. and it's going to be an account for 10 years, and it's an interest rate of 6.5%, but we're going to look at it if it's compounded at different amounts. So the first one will be compounded semi-annually. And again, with semi-annually, that is going to be twice a year, so n will be equal to 2 there. And remember, for our formula, if it's not compounded continuously, we're going to use our formula. A is equal to P times 1 plus the rate divided by the number of times compounded raised to the nt power. So semi-annually will be A is equal to, and we have 5,000 times 1 plus our interest rate is 6.5%, so 0.065. N is semi-annually, so it's 2. And then for our power, we're going to do 2 times 10 years. Okay, and again, do those parentheses first. So I'll take my 65 thousandths divided by 2 and add 1. So it will give me 5,000 times 1.0325 raised to the 20th power, because I got that by multiplying 2 times 10. And let's do our 1.0325 raised to the 20th power. That gives me 5,000 times 1.895837.924. And when I times that by 5,000, again, I'm going to round to the nearest hundredth, so I'll end up with $9,479, and it's 0.8962, because we want to round to the hundredths. It's going to become 0.19 or 19 cents. All right, so that's how much I would have if it's compounded semi-annually. Next, let's take a look at it compounded quarterly. So our formula is going to remain similar. We're going to have A is equal to, and it'll be 5,000 times 1 plus, our interest rate stays the same, so 0.065. But now N is 4, not 2, and it'll be 4 times 10 for my exponent. So when I do the math there, take my 0.065, divide it by 4, add 1, and I end up with 5,000 times 1.01625 raised to the 40th power, because I just did 4 times 10. So let me raise that to the 40th power. And I have 5,000 times 1.905558755. And again, you never want to round until the very end. We'll times that by 5,000, and we end up with $9,527, and it's 0.793, so it'll be 79 cents. All right, so next we're going to look at compounded monthly, and monthly is going to be 12 times a year. So N here will be 12. So our formula is going to be, we'll have our $5,000 times 1 plus our interest rate of 0.065 or 6.5%. divided by 12, and our power will be 12 times 10. So that gives us 5,000 times, if I take my 0.065 divided by 12 and add 1, I end up with 1.005416667, and it's raised to the 120th power. So that will give me 5,000 times 1.912183752. And I'm going to multiply that times 5,000. And I end up with $9,560, and it's 0.918, so it'll be 92 cents. And you should notice each time, the more you compound it, the more money you'll have at the end of time. So semi-annually was a little bit less than quarterly, and quarterly is a little bit less than monthly. So our last one we're going to do is continuously, and with continuously, you are going to use the formula up here, A equals P times E to the RT power, and E is an irrational number approximately equal to 2.71828. There is an E button on your calculator that you will use. So we're going to have A is equal to 5,000, because that's our principal, times E raised to, and then our power is going to be our rate, so 0.065, and our time is still 10 years. So really what we're going to end up with is 5,000 times E to the, when you multiply this to get your power, it's going to be the 0.65 power. I'm going to do E first. And the E button is on the TI-84 or graphing calculator or the Texas Instruments. If you look at the on button and go up 2 buttons to the, it says LN on it, it's a natural log button. Above it in blue, it should say E to the X power. That's what you're going to need to use. So you're going to do second LN and then put in your exponent. So I put in my 0.65. And if you want to check it to make sure it's right, I got 5,000, because I didn't multiply it by that yet, times 1.915540829. And then I'm going to multiply it times 5,000. And my final answer is, I'm going to put it up here so I have more space, $9,577.70. And that would be compounded continuously. And that's the only time you'll use that formula of A equals P times E to the RT power. So the last thing we're going to look at for this section is how to calculate present value. So here, I want to know what my principal is. I know what I need in the future. So I know A, but I want to find out, I know my rate, I know the number of times compounded and the time, but I want to figure out, well, how much money do I have to put into the account to get that money at the end of, like in, for instance, the first problem, the end of the 4 years. So here we want to know how much money should be deposited today in an account that earns 7%, compounded semi-annually, so remember N is 2, so that it will accumulate to $12,000 in 4 years. So to do this problem, I'm going to do P equals, and my A, my future value, is my $12,000, divided by 1 plus, my rate is 7%, so 0.07 divided by 2, because it's compounded semi-annually, raised to the 2 times 4 power, because it's n times t. So I will have 12,000, and on the bottom I'm going to do 0.07 divided by 2 plus 1, and it is 1.035, and it's going to be raised to the 8th power, because 2 times 4 is 8, so I'll raise it to the 8th power, and it gives me 12,000 divided by 1.316,809,037. And I'm going to take my 12,000, divide it by there, and I end up with $9,112. And here, we talked about this in 8.3. Whenever you're finding principal, you always want to round the dollar amount up, no matter what, to make sure you have enough. So it's 0.938, but we're going to make it 94 cents. And this one naturally rounded up. But whenever you find P, you always want to round your dollar amount up. So in order to have $12,000 in 4 years, I need to put in $9,112.94. So now for our last one, we want to know how much money should be deposited today in an account that earns 10.5% compounded monthly, so N would be 12, so that I have $22,000 in 4 years. So again, we're going to have P is equal to, and then I want $22,000. And it's going to be divided by 1 plus, my interest rate is 10%, so 0.105, or 10.5%. Compounded monthly, so N is 12, and it'll be raised to the 12 times 4 power. So we're going to end up with 22,000 over, I'll do 0.105 divided by 12 plus 1. So I end up with 1.00875, and that's going to be raised to the 48th power, because that's 12 times 4. So now I have 22,000 divided by 1.51918367, and when I do the division, I end up with, for my final answer, $14,481, and my money is 0.461, but again, because we're finding principal, we always round up, so we'll make it 47 cents.